Imagine standing on a beach, sweeping a metal detector back and forth over the sand. The rhythmic hum of the machine fills the air, interrupted only by the occasional rustling of the waves. Suddenly, a series of beeps erupts from the detector, signaling that something lies buried beneath your feet. Is it a lost coin? A rusty nail? A valuable piece of jewelry? How does a metal detector know the difference between these objects? Metal detectors work by generating an electromagnetic field that interacts with metal objects in the ground. When you turn on a metal detector, an electric current flows through a coil of wire in the search head, creating an invisible magnetic field that extends outward. As this field sweeps over the ground, it reaches any metal object in its path and causes tiny electric currents, called eddy currents, to flow within the metal. These eddy currents then generate their own secondary magnetic field, which the detector's receiver coil picks up and processes. Different metals respond to electromagnetic fields in different ways, and this is where a metal detector's ability to differentiate objects comes into play. One important factor is conductivity, or how easily electric currents flow through a particular metal. Highly conductive metals such as silver and copper generate stronger signals, while less conductive metals like iron and aluminum create weaker signals. This means a metal detector can distinguish a silver coin from a rusty nail by analyzing the strength and quality of the returning signal. For example, if you were searching near an old picnic site, your detector might indicate a strong signal, but by analyzing its characteristics, you could determine whether it's a valuable coin or just an old bottle cap. Another key factor is a property called phase shift. This refers to the time delay between when the detector's transmitted magnetic field interacts with a metal object and when the object's magnetic response reaches the receiver coil. Different metals produce different phase shifts because of their unique electrical properties. Gold, for example, has a phase shift that differs from that of aluminum or steel, allowing the detector to recognize it as a distinct material. To further refine its ability to differentiate objects, most modern metal detectors use a technique called discrimination. By analyzing the strength and phase shift of the returning signal, the detector can filter out unwanted items like nails and bottle caps, while focusing on more desirable targets like coins and rings. Many detectors allow users to adjust the discrimination settings, helping them ignore trash items while increasing the likelihood of finding valuable objects. Some advanced detectors use multiple frequencies to improve accuracy. Single-frequency detectors work well for general detecting, but multi-frequency detectors can analyze different metals more precisely by sending out a range of frequencies at once. This enhances their ability to separate valuable finds from junk, even in mineralized or wet conditions where signals can become distorted. For instance, searching on a wet beach could lead to interference, but a multi-frequency detector can better distinguish between a buried coin and a corroded piece of iron. Despite their ability to differentiate objects, metal detectors are not perfect. Some metals, like aluminum, can mimic the signal of gold, leading to false positives. A common frustration for treasure hunters is mistaking a pull tab from a soda can for a valuable gold ring. Additionally, the size, shape, and depth of an object all affect how it is detected. A small gold ring might produce a signal similar to a pull tab, making it challenging to distinguish between the two without experience or additional detecting techniques. Ultimately, the science behind metal detection is a balance of physics and technology, combining electromagnetic principles with advanced signal processing. While metal detectors can't tell you exactly what's buried beneath the surface, they provide enough information to make an educated guess. The more you learn to interpret the signals, the better you become at uncovering hidden treasures while leaving the junk behind.
Got a question about how something really works? Drop it in the comments and we might cover your topic in our next video.